Hello students, in today's video we will be discussing insertion on a linked list at a specified position algorithm. We will be dealing with this algorithm at specified position. Previously I have discussed with you insertion at end and insertion at beginning. I hope you are following the videos. If you haven't checked out, I request you to go to the description box of the video and check out these videos, because I will be using some of the previous knowledge which we used in our previous videos to decrease the time here to make things a little bit faster in this video. Okay, so now we have to do insertion at a specified position. Let's say I have a linked list. This is my linked list, this is a normal linked list, and I want to place this new node between 20, this element, this node, let's say this is the first node, this is the second node, this is the third node, or you can, this is node 0, node 1, node 2, like any denotation you can do. So I want to have this node between 2 and 3. So how we do it? I have this time create overflow read item. This is all just a gist of all these steps that we are having in the algorithm. So I will explain you. When you are doing this insertion, first thing what you will do is you will create a node, then you will check the overflow condition, then you will read the item whatever you want to have in that node, new node, then again empty list insertion. So there can be a case like in the previous video, if you remember, I discussed this linked list can either be empty, like it is having no element. So if it is having no element and I want to insert a node, then this condition false. Otherwise, if there is a linked list like this, then we will initialize our counters, make a loop, traverse, and then build a connection between these two nodes. This is how we will have to do. This is very simple. Just I have written for you to have this in your mind, and then you can expand and write the algorithm. Okay, so first step, we will create a new node. We have done it n number of times and name it new. Then we will check the overflow condition and exit. Then we will read new info item. So every node, every single node is having two things I have told you: info and next part. So this info part is the data. Let's say I want to store 50, so I will set new info equal to 50, so it will be stored here. Okay, then again this condition, if the linked list is empty, I will check if s is equal to null. If s is null, this means the linked list is not holding. S is null means linked list is not holding any node. I will set s directly as equal to new and the next of new equal to null, because there is no successor. There is not even a single node that is successor. So I'll set the next of new as null. I hope you are getting this point. If you are following the previous videos, this is very simple for you to understand these 4 steps. This is till here we have covered. Now let's say I have a linked list like this, and now I want to do insertion. So what will be my steps? Now this is also not that tricky. First, what we will do is we will initialize a counter that we are taking I, and we'll take a variable pointer. Pointer will be giving you your current location, current load location. We will be using this pointer for traversing. I have already covered traversing algorithm. I am assuming that you all know how to traverse. Okay, so again we will be discussing, that's not a big deal. So let's start. We will first initialize our counter and pointer. So initially my pointer is equal to s, that means my pointer is at node 0. I hope you understand. And my counter I is equal to 0 initially. Then there is this repeat steps 7 to 8 until I is less than POS, which is position. POS means position. Okay, so somewhere they will be writing LOC location or POS position. In different books you will be getting different way of interpretation. Okay, so now we will be repeating these two steps. This is kind of a loop that we are going to run. So according to this, I will set my pointer is equal to pointer next, right? So the next here is having the address of node 1. So I will put my pointer is equal to pointer next. It means I am saving the address of this next node 1 into my pointer and incrementing the counter. My counter becomes 1 once this loop has worked, and my pointer goes to here because pointer has increased and it has gone to the next node. I have traversed and incremented my pointer. Now the catch here is that I have to do this steps till only if my I is less than position. Now here the position is 1 because I want to insert after node 1. This new node I want to insert after 1. Now after this one step, I cannot move any further. I cannot have this working. So what I will do is I will move to the next. So our loop will get terminated because this condition is not satisfied, and we will move to our next point. Next point says, if you remember, I wrote it connection. So I need to build a connection between node 1, node 2 and new. Let's see how we do it. Okay, so for establish this connection, you need to understand that this is our pointer PTR. It is at node 1. This is new and this is my node 2. This pointer next, if I see this is next. This pointer next is having the address of this node 2. But if I attach this node in between, then this address of this node 2 next should be contained in the new node. I hope that is clear, because this address should be contained here because this will now be pointing. If you see, previously node 1 is pointing to node 2 now, but if I join this adjoining node, the new node will be connecting with the node 2. So what we will do is we will set new next. So news next is equal to the next of pointer. I hope you understand how we are establishing the link. And pointer next, so now we have said this is equal to this, and now it is having condition, it is having the address of this node. Again we will replace this because this new node is also having address, and the node 1 should be having the address of new node. I hope you are getting. इधर इसको एड्रेस चाहिए इसका, इसको एड्रेस चाहिए इसका, तो मुझे ये इस हिसाब से करना पड़ेगा चेंजेस एड्रेसेस में, ताकि एक कनेक्शन एस्टेब्लिश हो जाए. सो दिस इज व्हाट वी हैव डन. वी हैव पुट पॉइंटर नेक्स्ट इज इक्वल टू न्यू, pointer next is equal to new to establish this whole relationship between these three nodes, and then we can simply exit our program. I hope this much is clear to you. If you have any doubt, feel free to ask me in the description box. I request you to follow our channel. We have all the videos for your help. I will always be happy to help you. Request you to subscribe, like, share and comment. Thanks for watching.